Hello students, let's learn some basic concepts of mechanics. Let's start with the mechanics. Now consider this body. What this man is doing? He is giving push type of force to this body. Now what this man is doing? He is giving pull type of force to this body. Now the motion of this body, that is towards this direction, towards the direction of force. Right? Now, what is the mechanics? That is nothing but it is a branch of science that is dealing with the effect of forces on body. Next, matter. Again, it is very easy. Students, consider this particle. Now tell me, is this particle have weight? Does this particle have shape? Does this particle that occupies space? So matter, that is nothing but it is made up of a smaller particles which is having weight as well as it is having shape and it also occupies space. Now, when a matter is bounded by closed surface, it is known as a body. Again, consider these all matters. All are bounded by closed surface. So it is known as body. In term of mechanics, we term every body as rigid body. So here, let us understand rigid body. Now, consider this body. Now the forces is acting from this direction as well as from this direction. Then what about the resultant? What about the resultant? Now see, do you find any change in shape? Do you find any change in size? Do you find any change in distance between small particles? No, right? So here, in this rigid body, the distance between particles, or you can say the shape and size of body, that remains same even after application of force. Now students, tell me, is it possible in real world? No, it is not possible. Real body is imaginary body, because if body is not deformable with the smaller force, it is definitely deformable with larger amount of force, right? So when the distance between particle does not change after application of force, that body is rigid imaginary body. Next, deformable body. One distance between particle changes. Now after application of force, you can say the shape and size of body changes as well as the distance between particle also changes. So this body is deformable and every body is deformable. Now next term is inertia. To explain inertia, let I give you very simple example. When you are driving cycle or you are driving car, and suddenly if you are applying brakes, what will happen? For the change of state from motion to rest. So may you have feel that your body that offers resistance. Car offers resistance against the change of state from motion to rest. Okay, so that is nothing but that is inertia. Due to mass of body, there is a property is there in every body, and that property is inertia, right? So every body that is offers resistance against the change of state, either it is from motion to rest or it is from rest to motion. So that property is nothing but it is inertia. Now weight, it is a force of attraction due to which every body that attracted towards the center of earth. Now to explain mass, you consider these three objects. Now quantity of matter in this particular object is less, again more in this object, again more in this object. So if the quantity of matter is more, the mass of that particular object is more. So mass is nothing but it is a measure of amount of matter present in object. Okay, and it is measured in gram or kilogram. Now as you all know that mass of body that will be constant at each and every planet. What about the change? Change in weight due to gravitational acceleration constant. Weight of the same body that will changes. Over here it is 200 and over here it is 1200 because the planets are different, right? So because of change in G, the weight of body that will be different at different planets. Now we have two basic divisions of mechanics. One is statics, another one is dynamics. In statics, body it is at rest. In dynamics, body it is in motion. Students, let us understand the same by simple examples. To consider statics, to explain statics, first you concentrate here. Now consider this body, it is in rest position, right? In rest position, what about the type of forces acting on this body? One is the weight of body towards downward direction. Another one is reaction floor that is in upward direction. Reaction from this floor that will be in upward direction, right? So when you study the effect of forces on this particular body which is at rest, that will come into statics part. Okay, that will come into statics part, right? Now next, dynamics. Now we consider this body that is in motion due to applied force. Force is applied towards this direction, right? And the motion is also there in this direction, right? And friction is opposite to the motion, so it is in this direction. The weight of body that is exactly downwards and reaction from floor in upward direction. Now when you study this body, or you can say when you study the effect of forces on this particular body, that study that will come into dynamics part. Okay, so again it is a branch of science that is dealing with the effect of forces on body that is in motion. Now again we have two subdivisions of dynamics. One is kinetics. Again let us understand the same by a very simple example. Now we consider this cycle. When you drive cycle, students, tell me, mass of cycle is important or not? Can you drive say 100 tons of weight cycle? No, it's not possible. Mass of cycle is very important. When you drive cycle, force of legs that causes the motion of cycle, is it important? Yes, it is also important, right? So when you're driving cycle, mass as well as force causing that motion, that is also important. When you're playing with ball, the same way mass as well as force causing the motion of this object is also important. When you move table from one place to the another place, same way mass as well as force causing the motion, it is also important, right? So when the body that is in motion as well as you are considering mass as well as force causing the motion, that study that will come into kinetics. Next branch is kinematics. Now consider this body, car. Now tell me, when you drive car, mass of car is important to you or not? It is not important to consider. Now force that causing the motion of car, is it important to consider? No, it is not important to consider. You are dealing with the velocity, you are dealing with acceleration, but you are not dealing with the mass of car as well as force that causing motion of car. Remember students, I am not telling mass and force causing motion is not there. It is there, but it is not important to consider, right? So that study that will come into dynamics. When you are studying a body where the mass as well as force causing motion is not important. Again, the body that is in motion. Next, Newton's law. Although you know all laws, but let I understand the same by simple examples. Here, consider this body. What is the state of body? Rest condition. Now consider this body. What is the state of this body? It is in motion, right? Now, if you don't give any type of force, do you find any change of state? No. Right. So until and unless you are not giving any type of external force to any particular body, the state of body will not change. If it is at rest, it will be at rest. If it is in motion, it will be in motion. Now, Newton's second law of motion. Now, again, consider this man. Okay, he's playing cricket. Now, students tell me, when the ball that is thrown by bowler, what about the velocity of ball? And after hitting the same by the batsman, what about the velocity of ball? In both cases, the velocity is different, right? In case 1, velocity is less. In case 2, velocity is more. And mass of ball, that is constant. Now, what is momentum? Momentum is mass multiplied by velocity. Again, mass remains constant and velocity changes after application of force. Okay, so that is what momentum. So, we can say the rate of change of momentum, that is exactly proportional to the given force of bat, right? So, what the second law says? Rate of change of momentum of body is directly proportional to applied force. Now, third law of motion. Although everyone knows that every action have equal and opposite reaction. If the force is applied to this wall is say 10 kilonewton, then definitely the 10 kilonewton is there in opposite direction, right? So every action have equal and opposite reaction. So students, I will be very happy if you send your query to the structural engineering concept at gmail.com, and more lectures are there, and please like, share and subscribe. I hope the lecture is helpful to you and it is just for your help. Thank you so much. Thank you for watching.